Hello. In this video, we will continue solving equations. This is the second part of the video on solving equations. If you looked at that video, you will recall that when solving equations, we can have solutions that are one, identity, or we can have conditional, which is the one that you are more familiar with. Okay, it's conditional. Or we can have something that's a contradiction. And in the first part, I showed you examples on all of these. Okay. I also had ended that video in solving quadratic equations. We looked at solving quadratic equation by completing the square. So I am going to continue this video by doing an example of that, and then we will move into more depth. So solve quadratic equation by completing the square. So if you're asked to solve x squared plus 4x minus 32 equal to 0. And we said the first thing to do is move that c term to the right side of the equal sign. So x squared plus 4x minus 32 equals 0. We'll do that by adding 32 to both sides. Okay. And if we add 32 to both sides, we are left with x squared plus 4x is equal to positive 32. Now, we want to make sure that the coefficient a is 1. And in this example, it is 1. Okay. So if it wasn't 1, I'll show you in the next example, we'll have to do some form of factoring. So we have x squared plus 4x, and that is equal to 32. And now what we do, we take the absolute value of b, because that's your b. So the absolute value, okay, and we divide that by 2. And you have to square it. So we're going to add 4 over 2, the absolute value of it, and square it. And the only reason I said absolute value, because even if it was a negative, when you square it, it will become positive anyway. Okay. So you can tend to overlook the absolute value part that I'm saying, but generally that's what's going to happen. So now we have x squared, okay, and now we want to factor this. So plus 4x plus the absolute value of 4 is 4. Divide that by 2, you will get 2. And notice I don't say it 2 squared is 4. And I will show you that. Okay, I will show you why I do that. So right now we have x squared plus 4x plus 2 squared equals 32 plus 2 squared. Okay. Now we have to factor this. And the shortcut, what is really happening, and this will always work, there is only 2 terms with a square here, these 2. Okay. So I will put the square on the outside. And I bring down the x, always the signs as follows. So if that was a minus, this would have been a minus. Since it's a plus, I put a plus. And then the next term of the square is a 2. And you will see if you expand this and do it, it will work out for you. Okay. And then on the right side, we have 32 plus 4. So we have x plus 2, quantity squared is equal to 36 now. Okay. Now, we're solving, so we'll get rid of the square. And to get rid of that square, we'll take the square root of both sides. And don't forget that becomes a plus or minus there. Okay. So what we're left with is x plus 2 equals the plus or minus the square root of 36. And square root of 36 is a perfect square, so 36 is a perfect square, so we have x plus 2 is equal to plus or minus 6. From here, I like to split it in two because this means x plus 2 is equal to 6, and x plus 2 is equal to minus 6. So if we minus 2 on both sides, we have x is equal to, the plus 2 and the minus 2 becomes 0, and this is 4. And if we minus 2 in the other part, so we have x, the plus 2 and the minus 2 cancel, is equal to minus 8. So here are my two solutions for that particular problem. Okay. Now, if we look at an example, okay, let's solve by completing the square. So by completing the square, and we have 3x squared minus 4x minus 7 equals 0. So as we said, we'll move c to the other side. So we take our equation, 3x squared minus 4x minus 7 equals 0. I'm going to add 7 on both sides. Okay. And if I do this, we have 3x squared minus 4x is equal to 7. Now, as I said before, you want to make sure that that coefficient a is 1. Since it's not 1 in this case, what I'm going to do is factor out 3. And if I factor out 3, we have x squared minus 4 over 3x. And that is equal to 7. So my plan here is to now complete the square of what's left in the parentheses, right? This here is what will complete the square for this portion here. Okay. So when a is not 1, it becomes a little bit more detailed. I don't know if that's the right word that we want to use. X squared minus 4 over 3x. Remember, our goal is to always add whatever b is. In this case, the b is 4/3. And we have to divide it by 2. Well, dividing by 2 is the same as multiplying by 1/2, right? We know we have to square it. So if you multiply that by 1/2, you will get 4 over 6. Okay. And if I add it there, I have to add it to the other side also. But remember, whatever is in here, okay, is multiplied. Note, this is multiplied by 3. And that 3 is coming from here. Okay? That's where the 3 is coming from. So what I'm trying, and the reason I pointed out, that means on this side, you're going to have to multiply whatever you have in red by 3 also. So 4 over 6 squared. Okay. And that's very important because many times we overlook that. So we have 3, then we have our x squared minus 4 over 3x. And in red, we have plus 2 over 3 quantity squared. Okay. That is equal to 7 plus 3, and then this becomes 2 over 3 squared. Now, if we factor the inside here, if we factor this, the 3 comes down, and in there, like I said before, the x will come down, that sign comes down, and whatever this is, so that becomes 2/3, and the square goes on the outside. Okay, that's the whole idea. Okay. And then on the right side, we just simplified. So we have 7 plus 3 times 4 over 9, because 2/3 times 2/3 becomes 4 over 9. Okay. If we now multiply that by 3, so my 3 comes down, x minus 2/3 squared is equal to 7 plus, this becomes 12 over 9, right? If we distribute, 3 times 4 is 12. Okay. So what do we have? We have 3 parentheses x minus 2/3 squared is equal to, now find the common denominator, which will be 9. So this becomes 63 over 9 plus 12 over 9, right? Common denominator. So we have 3 parentheses x minus 2/3 squared is equal to 75 over 9. Okay. Now we have to get rid of the 3. So this becomes x minus 2/3 squared equals 75 over 9. And to get rid of this 3, I can multiply by 1/3 or divide by 3. So this will cancel out, leaving me with x minus 2/3 squared is equal to 75 over 27. And 75 over 27 can be simplified as 25 over 9, right? You can divide here by 3, divide there by 3. So this becomes x minus 2/3 squared. And then from here, we take the square root of both sides. So x minus 2/3, we take the square root of both sides. And as a reminder, plus or minus, okay? So we are left with x minus 2/3 is equal to plus or minus the square root of 25 over 9. And we do know the square root of 25, it's a perfect squared. And we do know the square root of 9, so this becomes 5 over 3. And then from here, we have two problems. We have x minus 2/3 is equal to positive 5/3. And we have x minus 2/3 is equal to negative 5/3. Yeah, those are my two numbers I'm looking at. So if we take x minus 2/3 equal 5/3, and we add 2/3 to both sides, if we add 2/3 to both sides, then we have x, this will cancel out with that, and since the both denominators are the same, this becomes 7/3. So here we have an answer. The same thing we'll do here, x minus 2/3 is equal to minus 5/3 if we add 2/3 to both sides. Okay, let's do that in a different color. If we add 2/3 to both sides, then what will happen is that this will cancel out with that, so x is equal to minus 3/3. And minus 3 over 3 is the same as negative 1. So here are my two solutions, okay? Either one of these will make them, that statement, correct. Okay? So that's the process of completing the square. Like I said, there are more ways to, or different approach to how you solve. But I like showing it this way because it helps you later on if you have to graph these equations, okay? So now we'll look at the quadratic formula, okay? The quadratic formula, which we had earlier, minus b plus or minus the square root of b squared minus 4ac, and make sure all of it is over 2a. And we'll use the quadratic formula to solve quadratic equations. Quadratic equations, okay? Quadratic is ax squared plus or minus bx plus c equals 0. So that's something you have to remember when we solve what a quadratic is. And please remember that a cannot be equal to 0. So if you're given an equation, I'm asking you to solve by using the quadratic formula. Solve by using the quadratic formula. An example, we have x squared plus 3x is equal to 9. So the only thing that we have to make sure for a quadratic formula is that it's equal to 0, right? Or solving quadratics in general. So this must be equal to 0. So if we have x squared plus 3x equals 9, and we subtract 9 on both sides, this will leave us with x squared plus 3x minus 9 equals 0. So here now we have a is equal to 1, which is that coefficient, b is equal to 3, which is the middle number, and c is equal to minus 9. Okay, now if you didn't move that 9 to the left side, you would have said something else, so be careful. Now if we use the formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. So we plug in, we have minus. Instead of b, I'm going to write 3. Okay, then we have plus or minus the square root of, instead of b, we write 3 again. And then we have minus 4. And instead of a, we put the number, and instead of b, we put the number. So for a, we have 1, and for c, we have minus 9. Okay, let's write that properly. Minus 9. So it's 4ac. Okay, I think I said a b there just now. Divide that by 2, and instead of a, we write 1. So now we just simplify. So we have x is equal to minus 3 plus or minus the square root. 3 squared becomes 9. And then if we multiply this out, the 2 negative will become positive, and 4 times 9 is 36. All of that over 2 times 1 is 2. So we have x is equal to minus 3 plus or minus the square root of 45 over 2. Now 45 can be simplified. It's not a perfect square, so I can rewrite 45. I can rewrite 45 as 9 times 5. Okay, all of that over 2. And the 9 can be extracted out because it's a perfect square, so that becomes 3 root 5 over 2. Okay, the square root of 9 comes out to be 3. Now, the only thing I can do here is, or I can say it from this point, I like to split it up. Okay, so if I split this up, I have x is equal to minus 3 plus 3 root 5 over 2. or x is equal to minus 3 root 5 over 2. And try to see if you can simplify or if there's anything else to simplify. Clearly, if you look at this carefully, you will see that there is nothing to be simplified, okay? So you just have to check your work to see if any simplification can be done. So the quadratic form is just a matter of plugging in numbers and replacing those appropriate letters, right? Now, how about if we have polynomials of higher degree? Higher degree. Remember, degree just means the exponent, right? So suppose that you're asked to solve, example, solve 3x to the fourth is equal to 48x squared. Now, anytime the degree is higher than 1, you have to do some sort of a factoring, right? So the first thing we'll do is set it equal to 0. So 3x to the fourth is equal to 48x squared. What I'm going to do is minus 48x squared on both sides. If I do this, okay, I have 3x to the fourth minus 48x squared, and that is equal to this. Will cancel out with that 0. And now we can factor. The GCF happens to be 3x squared. So if I factor out 3x squared, that leaves me with x squared minus 16 is equal to 0. And now we can factor here again. Okay? So we have 3x squared, x minus 4 times x plus 4 is equal to 0. Because this here is difference of square. Okay? Factoring again now. Now each one of these is a factor. This is a factor. This is a factor. And this here is a factor. Okay? So take each factor and set it equal to 0. Okay? Always each factor, once they're in multiplication, you set them equal to 0. And now we solve each one of them. So in the first scenario, I'm going to divide both sides by 3. And that leaves me with 1x squared is equal to 0. And then we take the square root of both sides. And we're left with x is equal to plus or minus 0. Square root of 0 is 0. Therefore, x is just 0, right? If I do the same thing for the other two cases, we add 4. And here we have x is equal to the minus 4 and the plus 4 cancel. So let's just draw a line there to make sure it's 4. So here is the second answer. And then in my next scenario, we minus 4 on both sides. So we have x is equal to the plus 4 and the minus 4 cancels. Okay. So we have x is equal to negative 4. Okay. So we have x is equal to 4. Or if we draw a line here as we did before, we have x is equal to negative 4. So any one of these three answers will make that correct. Okay, any one of them. So polynomials of higher degree is that you want to break it down to see if you can factor. Okay, let's look at another example. Solve x cubed now minus 3x squared minus 3x plus 9 is equal to 0. So note, right, you should recall, note, we have 4 terms here. So we can try factor by grouping, right? It may work. It may work. So what does factor by grouping really means? It means take the problem and break it into two problems, right? Think as one part of your problem as this portion here, okay? And the next part of the problem as this portion here. Okay? So I generally just put a line down the middle so we don't get lost. And the GCF is x squared. This should have been an x cube, right? X cube. So if I factor out x squared, what we have left is x minus 3. Okay, the GCF on this side becomes negative 3. This sign I always take with the GCF. So we have minus 3. Maybe I should write this in purple. And what's left, we have x minus 3 equals 0. Now be careful, or should observe and be careful that these parentheses for grouping to work must be the same. If not, grouping is not working or you made a mistake, okay? So not only is it the same, but that's GCF again, okay? Take out that GCF of x minus 3, we have x minus 3, and we have left x squared minus 3, and that is equal to 0. So notice now, this is a factor, and this is also a factor. So as I said before, take each factor and set them equal to 0. So here we can add 3, and what is left is x is equal to the minus 3 and the plus 3 cancel, so x is equal to 3. Okay. On the other part, I will also add 3, and what do we have left? We have x squared is equal to 3. But then to get x by itself, we'll take the square root of both sides. Okay, so now we have x is equal to plus or minus square root of 3, which really means that x is equal to the square root of 3, or x is equal to minus square root of 3. Okay, so, and don't forget we had x equals 3. So here are my 3 answers. Okay, here are the 3 answers. So we've seen quadratic, we've seen by completing the square quadratic formula, by factoring. Let's look at some equation that involves radicals. So equations with radicals. Okay. So example, how about if I ask you to solve the square root of 2x plus 7 minus x is equal to 2. So remember, your goal in solving radicals and absolutes, right? The goal here, is, or the first goal, I should say, is to leave the root by itself. Okay. So if we have the square root of 2x plus 7 minus x is equal to 2, what I'm going to do is add x to both sides. If I do that, if I do this, we have the square root of 2x plus 7, the minus x and the plus x cancel, leaves with x plus 2. And now I can actually square both sides. So once the radical is by itself, we are allowed to square both sides. So we have 2x plus 7 and x plus 2. And what we do now, we square both sides. Okay? By squaring the left side, the root will cancel out. So we're left with 2x plus 7. And if we square this side here, this becomes x squared plus 4x plus 4. And now notice we have a quadratic. Okay, this is quadratic. So it has to be equal to 0. So that means we have to move the 2x and the 7 to the right side. It doesn't matter which one you move first. We can move the 7 first. And if we do this, we have 2x plus 7 and a minus 7 cancel is equal to x squared plus 4x minus 3. And then once again, we can subtract 2x on both sides. And if we do this, this and this becomes 0 is equal to x squared plus 2x minus 3. So our quadratic is x squared plus 2x minus 3 equals 0. This is our quadratic. Okay. Now, let's try to factor. Okay. If we try to factor this, we get x plus 3 and x minus 1 equals 0. This is a factor, and this is also a factor. So we can take each factor and set them equal to 0. And then we solve, so we minus 3 on both sides. So we have x is equal to the plus 3 and the minus 3 cancels, negative 3. Similarly, we add 1 to both sides, and x is equal to, because this will cancel out, negative 1 becomes 0, and plus 1, 1. So our two answers are x equals negative 3 or x equals 1. Okay, those are my two answers. Let's look at another example. Let's solve the root of 2x minus 5 minus the root of x minus 3 equals 1. Okay. So remember, the goal is to always leave, your goal is to always leave a radical by itself. Once one of them is by itself. So what I'm going to do, we can take what we have, the root of 2x minus 5 minus the root of x minus 3 equals 1. And we're going to add or subtract whatever. So if you subtract this one here or you add this one, okay? So in this case, we're going to add the root of x minus 3. And if I do this, we have the root of 2x minus 5. This will cancel with this, is equal to 1 plus the root of x minus 3. And now we can square both sides. Okay. We can square both sides. And if we square both sides, we have on the left side 2x minus 5. On the right side, we have 1 plus the root of x minus 3 times 1 plus the root of x minus 3. And if you FOIL that out, 1 times 1 is 1. 1 times the root of x minus 3 becomes plus the root of x minus 3. And this times 1 becomes plus 1 times the root of, this is a 1 here, x minus 3. And then we have the root of x minus 3 squared. So combining like terms, we have 1. These are like terms, so we have 2 root x minus 3, and then plus x minus 3, because this square will cancel the square root. Combining like terms again, we have 2x minus 5 is equal to 1 minus 3 becomes negative 2 plus 2 root of x minus 3. So notice again, we have a radical here. We do have a plus x, right? Plus x. We do have a radical here. So our goal once again is to leave that root by itself. Okay, so leave the root by itself again. So we add 2. If we add 2, we now have 2x plus minus 3. This will cancel with that. And we have 2 times the root of x minus 3 plus x. Now we can subtract x from both sides. And if we do this, we will have x minus 3 is equal to 2 root x minus 3. So notice our root is by itself. Okay? If the root is by itself here, what I can do is square both sides. We can square both sides. So we have x minus 3 is equal to 2 times the root of x minus 3. If I square both sides, that will get rid of the square root. Okay? So we have to square both sides. So by squaring, if you square this, you get x squared minus 6x plus 9. And when you square the side, this gets squared also, so you get 4 times x minus 3. Okay? So we have x squared minus 6x plus 9 is equal to, and if we distribute, we have 4x minus 12. If we set this equal to 0, or minus 4x on both sides, and we're setting it equal to 0 because it is a quadratic again, so we have minus 10x plus 9 plus 4x and minus 4x becomes 0. And then we have to add 12 to both sides. And if we do this, we now have x squared minus 10x plus 21 is equal to 0. And we want to factor this if possible, right? So let's try to factor. If we try to factor this, x squared minus 10x plus 21 equals 0, okay? We can factor this because we get x minus 7 and x minus 3 equals 0. So here we have a factor, here we have a factor. Okay? So if we solve or take each one of them equal to 0 first, and we solve, we get x is equal to 7 here, or x is equal to 3 here by solving. Okay? So, you know, it is important to be careful with the algebra because you can easily get lost, right? We can easily get lost in our process. So very important for us to see what's happening. We can also look at some equations equation with rational exponent. Yeah, exponents. For example, if we say to solve x minus 5 raised to the 3/2 power, and that is equal to 8. So we can write rational exponent as roots, right? Remember, the denominator tells the root, right? The denominator tells the root. Okay? So this is the same, since the denominator is a 2, the square root of x minus 5 cubed is equal to 8. Okay? So you can see that if I square both sides, that square root will go away. So now we have left x minus 5 cubed is equal to 8 squared, which is 64. Okay. 8 squared is 64. And now to get rid of the cube, okay, what we can do is take the cube root of both sides. Okay. And we will be left with x minus 5 is equal to the cube root of 64, which is just 4. We can then add 5 to both sides, and that will leave us with x, the minus 5 and a plus 5 becomes 0, is equal to 9. So here is our answer. Now remember, when you have roots, you should check your answer. Okay, check your answer. Very important. So it is important to always check your answer, especially once we have roots and radicals and inequalities, right? These are very important things you have to check. Very important. Okay. We can also look at equations with absolute values. Equations with absolute value. For example, if we have 2, the absolute value x minus 3 plus 6 on the outside, and that's equal to 18. So this is very similar to the roots. Remember, your goal is leave the absolute value sign notation by itself. Okay. So what we'll do is we will move first the plus 6. We can do that by minusing 6 on both sides. Okay. If we minus 6 on both sides, that gives us 2, the absolute value of x minus 3. The plus 6 and the minus 6 becomes 0, and 18 minus 6, that's 12. And then we still have to leave the absolute value by itself. So now divide by 2 to get rid of that 2 on the outside. So this cancels out. So the absolute value of x minus 3 is now equal to 6. Just a word of caution here. You're not allowed to distribute into an absolute value, okay? Word of caution. cannot. And from here, we now have two problems. We have x minus 3 is equal to 6, and we have x minus 3 is equal to negative 6. So if we solve, we can add 3 to both sides. And here we have x is equal to 9. Right? And then likewise, we solve the next part by adding 3. And we see that x is equal to minus 3. And as always, check both answers. Okay. Now, when you do this, you will see that, so this is something you have to do, that both of them will work. Okay. So the answer is x equal 9 and x equals minus 3. So here are your two answers. Now, as always, you need to practice and practice and practice, because practice is what makes this better for you, okay? So practice will make it better for you. So please try as many examples as possible.